Stereo depth sensors in theory and practice. First off, thanks everybody for being here. This talk is a little different from our other webinars because as our other webinars were more product focused, diving into what we can do with our software and how it applies to robotics. This talk is going to be more business focused. So really, this is a condensing of some learnings we've done while developing Hi-Fi and also contextualizing the market. And what I mean by that is we've done a lot of market research around Hi-Fi and depth sensors while we've been going through this process. And those insights are really interesting. We'll get into the gist of the talk, but really the bottom line is that depth sensing is not a commercially solved product. And we'll get into a lot of examples of why this is later on. But really the whole thesis of this talk is, we're making depth sensors for robotics. Other companies are making depth sensors for robotics. There are future plans to make depth sensors for robotics. And one would think that, similar to cameras, if you get the general form factor correct, you're hitting the mark. We found that that's not true. In fact, even Hi-Fi doesn't quite, in all of our aspirations, won't hit the mark the same way as Luxonis or Intel or future products that we have in mind. And so the begs the question, why? Why is this not commercially solved? Why is this thesis that I'm presenting true? Or, argued to be true? So let's get into that. So context for this talk, I gave this same talk at Robotics Summit 2024 this year, mostly around sensing technologies. But it was important that the audience know that really this is not a sales pitch. Hi-Fi is great. I love Hi-Fi. We're really excited for what that's going to bring to the robotics market. But this is not about Hi-Fi and what it can do. Again, this is about the market and how we've reacted to it and how we continue to see other companies do the same. So for context, Tangram Vision, we focus on perception, long-term autonomy, and scaling robotics companies. If you're scaling, we fit in. Hi-Fi is kind of our flagship 3D sensor. We originally launched this on Kickstarter. We can talk later about whether or not that was a boon or a bust. For us, I think Kickstarter still makes sense in hindsight because it gave us a lot of these learnings about the market. In case you don't know, Tangram Vision, a lot of the company has built 3D sensors before. As I would say in the slides, this is not our first rodeo. We kind of know the ins and outs. We know why depth sensors would be needed and what configurations users are going to look for in their depth sensors. So we had a baseline of knowledge before we even took this approach. But really what we're building Hi-Fi for is to focus on great depth for long-term autonomy. And again, this begs the question, what is great depth? What does that do for long-term autonomy? It's part of the picture. But first, before we even get into the learnings, why use a stereo depth sensor at all? This is the theory of it. Depth sensors just provide a richer understanding of the world to inform autonomous actions. You're able to see, you're able to sense depth, you're able to get a perspective of where you are versus where everything else is in a way that is richer than a camera. The precision of the sensor is a function of the camera quality. So if you have two really good cameras, you're going to get a really good depth sensor as long as your algorithms match. Calibration is obviously important here. A little plug for Tangram Vision's calibration products. We recalibrate other depth sensors in the market all the time. We have many customers who use Metrical day to day to do this in operation for sensors that we don't even touch. But that's not everything. The second reason one would use a stereo depth sensor is because it's very cheap, especially when compared to the, I would say the second most common solution to depth, which is LiDAR. If you compare these prices, I've kind of put together something quick and dirty. Most every depth sensor is going to clock in around $500. You can get a little cheaper depending on if you sacrifice some features such as passive versus active depth or connectivity or X or Y. But really, you're going to get under 500 mostly. Whereas LiDAR starts a little under 1,000 and only goes up from there. Of course, LiDAR has becoming more cheap. That's great. But I don't think even today you could find the equivalent LiDAR deal for a depth sensor that you would be able to find in the market, right? And so these two, in theory, this is why you would use a depth sensor. One, it gives you really rich knowledge, especially if you get your calibration and math right. And two, you get it for cheap. It's just two cameras slapped together to doing some algorithms. You can make that as sophisticated as you like, but at the end of the day, that's what you're getting. So great, depth sensors give you a lot for a little. That's awesome. We love that in robotics. But why so many iterations of depth sensors? Why do people keep making depth sensors? Why in practice are there more innovations happening? And what are those innovations? To look into that, let's analyze some survey data that we actually took during Hi-Fi pre-sales. This is totally anonymous. There are some trends that you can figure out from the data, but we didn't get names, we didn't get companies, nothing like that. But we're going to use this data as a proxy for the stereo depth sensor market at large. Since Hi-Fi had so many features and kind of competed so directly with, I would say, the market state of the art, we took these numbers to be pretty self-evident. But, you know, surveys are surveys. We can always pick them apart. So let's dig into it. Hi-Fi what we're going to do is look at the Hi-Fi survey highlights initially, and then we're going to analyze these a little deeper in the second half of the talk to understand what trends this indicates or what market forces are at play to make this happen. So Hi-Fi survey highlights. Immediately we have a bias towards people who are exploring sensor options. If you're happy with your sensor, you're not going to buy Hi-Fi, you're not going to buy any other sensor. You found your bomb, right? So these are users who are supposedly either unsatisfied with their sensor choice or are just curious about the state of the market because they, there's something bigger or better around the corner. First off, what 3D sensor brands do these users currently use? Overwhelmingly, we saw Intel RealSense and Luxonis. This makes sense from a market or from a price perspective. Intel RealSense and Luxonis are some of the cheapest on the market. They're also fairly well supported, just from sheer numbers. Kinect was second. Then Orbeck structure sensor, which is specifically for iPads and iOS devices. Stereolabs, which is strongly reliant on the NVIDIA platform, and Senso. And then the last that we included here was in-house design. And we'll get into a little bit of why that's interesting later. But for now, RealSense and Luxonis, a lot of people using that are using those sensors now, a lot of people looking for alternatives to those sensors at the same time. Do you plan to use Hi-Fi for a specific purpose? Now, since we launched this on Kickstarter, a lot of these answers were, maybe casual users of depth sensors. And what I mean by that is they're not using it in a commercial setting. They're more doing it for hacking, more interested in what it can do for their pet project. And that was a sizable amount of users. I would say about 20 to 30%, say 20% maybe. But everyone else who was in this survey had a strong commercial reason to be looking into these sensors. So obstacle detection, AI/ML, navigation, object identification, 3D scanning of various objects in rooms. All of these are very practical purposes for a depth sensor. And for some reason or another, their current depth sensor didn't fit the bill. Do you plan to use Hi-Fi in a specific industry? Again, setting aside the hackers, which again, say about 30% of respondents. Everyone else strongly favoring mobile robotics or AI/ML. There's robot arms and industrial automation also share a significant amount here. But what we found at Tangram specifically is that industrial automation is such a controlled and enclosed environment that you often don't need more complicated sets of sensors like what Hi-Fi would give you. What you're really looking for is something to do a very specific job. And so for industrial automation, that would probably be a pseudo bar scanner or something that understands depth in order to inform grip for a robot arm, for instance, right? And so mobile robotics, AI/ML, this slant makes a lot of sense, even without really looking into the data. Drones, the small share of drones also makes sense because drones have specific use cases and specific needs. For instance, if you're making a drone in the US, you may have FAA regulations, or you might need to be ITAR compliant, something along these lines. You need something, US based and IP67 rated and not controllable over USB so that you don't mess your GPS. A lot of these things make the drone market specifically hard to enter or very specific for a depth sensor, any sensor really. And so this underrepresentation makes a lot of sense. Which hi-fi feature interested you most or least? Now, this is interesting, and we're going to dive into a little bit of the analysis later. But of course, AI fit the bill. So around when we did this survey was when ChatGPT 4.0 came out. We had a lot of neural network movement or progress, a lot of demo videos coming out around this time. And so it made a lot of sense that the AI trend just continued via hi-fi. Hi-fi has 8 tops of AI. That's a lot, but it's not the most in the market. But what we've seen is that this quantity fits a lot of bills, and a lot of people are interested in taking it for a spin. The second most interesting features are depth error. Hi-fi expects to have sub 1% depth error at 5 meters. This is very interesting for users, as well as self-healing. So what that means is if hi-fi gets out of calibration, it will detect that and self-heal. This is not a feature that will come out immediately with hi-fi, but it is something we're in development with, along with auto calibration, right? And so these things will go hand in hand, and users of hi-fi will be able to just run that on their system. So all these were most interested. Least interested was Ethernet. This makes sense because unless you're in an Ethernet constrained environment, or you know that this is a requirement, you're probably more comfortable using USB. Hi-fi has both, which is great. And also the small size. Very surprisingly to us, what we found is that there's sort of an elastic size constraint for sensors in general. Really what roboticists are looking for are sensors that do the job to be done, not sensors that make a pretty rig, right? So I think that hi-fi's design is quite elegant. We haven't gotten any necessarily bad reviews on that, but size specifically was not a concern. So that's good to know for future iterations of hi-fi, for instance. The rest of these features are kind of middling. I think these, 1.6 megapixel depth, range, the field of view. Field of view is also very interesting. But again, that's very context dependent. So really, I think a lot of these features are table stakes for depth sensors now, and you're really looking for differentiators in the market. So all interesting, all good stuff. But now let's read between the lines as to what this actually means as far as a market signal. So if we looked back, originally, we saw a lot of Intel RealSense, a lot of Exonis, and then kind of bleed off after that until we got to in-house design. Now, if we look deeper into why this might be, my hypothesis, at least when I was putting this together, is that now you're looking for the jobs to be done. Like all of this is looking into why would you buy a RealSense, why would you buy a Exonis, and what are you utilizing from those sensors that give you the best or the most bang for your buck. For Intel RealSense, traditionally this has been the cameras. Intel RealSense system gives depth and camera feeds at a very consistent API. I think Intel RealSense's API is not the gold standard. I don't think anybody would say that, but it's so well understood and so ubiquitous in the robotics market that I think many robotics startups, product designers will use an Intel RealSense, even if they don't use the depth, just so that they can have a set of reliable cameras. And we've seen this a lot, just having casual talks anecdotally with robotics companies in the field. They'll have 4 Intel RealSense around, but they're only using one camera on each side, for instance, just to get that reliable camera quality. When it comes to Exonis, what we've seen, again, anecdotally, is that Exonis has pioneered the edge AI movement for depth sensors specifically. So their AI chips on each Luxonis sensor, their last generation had, I think, 1.4 tops of usable power, whereas the rest of the tops were reserved for Luxonis operations. And I think their next generation of sensors beefs that up, gives you more edge AI, kind of building on this trend of AI on the edge via a sensor, right? And so given their, I'm not even going to say ubiquity, given that they're really the only player on the market at this scale giving AI abilities, we've seen that most people bring Luxonis onto their system specifically for that. The depth not might be what they're looking for, but the AI capabilities make up for it. So again, they might just use a camera or two camera streams as two camera streams, not even as the depth, just to get object detection on the edge and bring those into their system. So really interesting. We're already finding, even on this first slide, we're already finding a dichotomy in the market for why you would use which depth sensor, even though they offer you the same data. Really interesting stuff. I would bucket Connect, Orbec, structure sensor. These are all bucketed with cameras. I think if you're using some more of these specialty solutions, especially Stereolabs and structure sensor, you are looking for good depth specifically. But you can see that that share of the market's not huge. For this bar is supposed to be an in-house design, by the way. If you're making an in-house design, you're definitely looking for depth, but for some reason, nothing in the market worked for your use case. And this could be for a variety of scenarios. We've seen compute restriction. We've seen focus, depth of field, different, fields of view. Once you get into stereo systems, esoteric stereo systems, there are a lot of ways you can kind of build that up. But bottom line, in-house design, still a very small segment, and it doesn't seem like a lot of customization is needed to get a depth sensor off the ground. So that's good news. If you're making a commercial depth sensor, the one size fits all or the 5 models fits all approach actually does seem to work. Very few users will opt for an in-house design, especially because it's too much work. So, if we're thinking about reasons why you would use a depth sensor in the market or build a new depth sensor, depth sensors are often used as cheap commodity cameras and AI devices, and they aren't depth sensors at all. We're gonna dig a lot more into this and kind of dissect that later in the demo. Here we go. A depth sensor just means more than sense depth, right? Because what you're looking for is a set of reliable cameras, a reliable depth stream, AI on the edge, and general computation. You're just gonna want to, if the more you can push to the edge in some cases, the better, because you really just want the information that's necessary for your application. In a SLAM system, you might just need detections. You don't need everything else. In navigation, you might need object detection or path planning. The more you can shove to the edge of that sensor, roboticists are realizing that there's real value in that. So now let's dive into the use cases for analyze the specific purpose. Like I say here, depth helps with AI, but it's not necessary if you just want to, image models on the edge. So what I mean by that is there are a lot of AI applications. I would say the majority of AI applications don't need depth at all. In fact, they wouldn't know what to do with depth. What you're really looking for is a raw camera stream or two to get what you need. And so again, this makes sense that users might go to a Luxonis or an Intel RealSense brand just to get those reliable cameras. However, there are a lot of other uses that actually do need great depth, right? And so you can think of, if you didn't bugger yourself into the AI ML, you're going to look for mobile robotics. Mobile robotics absolutely will need great depth to ensure obstacle detection, navigation, object identification. These things rely on great depth to inform you correctly. Same for the robot arm. As we discussed earlier, you might need object identification robust 99.99% of the time. Like if you're running a fast warehouse chain, you don't ever want that down. Ideally, it would be, dark factory kind of situation. Same with industrial automation. Same with drones. Drones, mobile robotics, anything moving within an environment is going to need great depth, and AI won't always cut it, right? And so again, we're seeing this dichotomy between what do you want to use it for? What is the job to be done? And then lastly, what feature interested you most or least? We're looking at this again. The most popular ones besides AI were all around depth. Self-healing depth, 130 field of view depth, high resolution depth, sub 1 pixel or sub 1% depth error. All of these rely on great depth. So there's a third bottom line here that's really interesting. And there's no throwing shade to anybody in the depth sensor manufacturing field. But depth sensing is also not commercially solved because roboticists are still looking for quote unquote great depth, right? So everything in this survey has indicated that you're either looking for this sensor for one of two reasons. One, AI is important to your AI on the edge specifically is important to your use case, and you want to push it out as far as possible away from the host. That's great. Two, you actually need great depth, and you're going to rely on that for one of your applications, one or more of your applications. The population between those is not split 50-50. I would say if you're looking for a depth sensor, you're definitely going to buy a depth sensor. If you're looking for AI, you might not buy a depth sensor for that purpose. But very interesting that there's such a skew in the market. So really, those interested in the 1 pixel depth error or 1% depth error, high depth resolution, self-healing, wide field of view, none of these have found a perfect fit for what they need in the market today, right? And I think that's fascinating because what that informs us of as depth sensor manufacturers now is that there is this dichotomy in the market between what we're building now, which is Hi-Fi, a complete sensor package with AI, ML on the edge, with high resolution depth sensors, does everything for you, and what could actually be useful for your system, which could be much more specific. It could be 2 cameras, 2 stereo cameras that just stream reliably in any scenario, or it could be an AI chip with 1 camera, where you just want AI on the edge as fast as possible. There are a lot of configurations that this survey brings up that aren't actually addressed in the market today in a way that makes sense for these use cases, right? So I hope that was coherent. Really, the bottom line is the depth sensors on the market today do a lot, and there's a lot of unification between them as far as features go. But there's an emerging thesis. The emerging thesis here from what we've seen is that may not always be the way to go. There's room in the market for quote unquote dumb sensors. There's room in the market for smarter, more simple sensor systems, as in simple being less cameras, less compute, but more to do on the edge. And there's a lot in between. There's a whole spectrum of designs that can fit with one or another of these applications, right? And so we've started with Hi-Fi, but from what we've learned, we may not end there, and there could be a lot of really fun things to come in the future. Anyway, Adam, how are we doing?
Good. Thanks for that presentation. We do have a couple questions that have come in. So I'll start with the first one. Let me sort of paraphrase this. What kind of techniques do you use to sync stereo pair images and other sensors to work with applications like calibration or stereo visual odometry?
That's a good question, in that there are a lot of ways to do it. Sometimes we don't, and I'll get to that in a little bit. But the most common, we'll ask customers to do their best. P2P hardware is always the best. So something that gives you a clock signal that everybody can understand. There's also P2P software. which is what hi-fi is going to be implementing. That gets you, to the microseconds, just microseconds of delta between images, which is perfectly fine for calibration and most any application you would need. But then sometimes they don't, right? We have customers who, in worst case, the delay between captures is nearly 2 seconds, right? So you'll see the move, and then you'll see something else move. And looking at these data streams makes you really nauseous because you want everything to work and it doesn't. But in these cases, there are algorithmic ways to approach it. Our motion filter does a lot of heavy lifting for this. We've kind of abused that in the past, but also auto calibration is going to use a continuous time model. So we'll just be able to kind of align these things as we go. So hopefully in the future, we won't have to worry about it because, our algorithms will just figure it out. And we're getting pretty near to that solution now, which is exciting.
Cool. Another question. So you said that some of the respondents to the hi-fi survey built their own depth sensors. How does one build their own depth sensor?
Painfully. The most common way to do it is to literally just make 2 cameras look at the same thing with a little bit of a baseline. That's the easy way, or that's the easy part, basically, making that baseline, making the cameras look the same way. Then you have to do camera synchronization, which we just discussed and I kind of glossed over. And then you have to make sure that your calibration is nearly perfect, because with just a little bit of twist, you're going to be getting invalid depth values or no depth at all. And then you have to create the depth algorithms. Luckily, this last part, it's not the easiest. It's the hardest part, but there are a lot of ready-made solutions on the market now if you need them. For instance, I think NVIDIA has a stereo depth pipeline through their Isaac platform. And so if you need depth in a pinch, that's a way to do it. But then you get into computation restrictions, because if you're running depth on every pixel and every 2 images, that's going to be a lot of throughput, even with a GPU. And so you're going to need to control that, or purchase a chip, a SOM, if you will, that does it for you. And so when we think about hi-fi's architecture, we're using the Texas Instruments TDA4AL, correct, Adam?
TDA4AL.
That's right. Yeah, but this is part of their Jacinto line of chips that all have some of this functionality built in, right? So without something like that, running in real time is almost impossible with these algorithms. So there's a lot to build up. Once you get there, then you have to tune it and make sure your heuristics work for every scenario. And if you're a mobile robotics company, that can be hairy as well. That can be like a year of tuning. So I wouldn't recommend it. The companies that did, like I said, had no other alternative, whether it was financial or technical. And so they just bit the bullet. And those customers, I wouldn't say customers, those companies were the most helpful when thinking about what to do with hi-fi, because you knew that they had gone through the same pain themselves and they wanted to know a way out, right? So
cool. We have one more question here. If anybody has one last final question after this one, please put it in Q&A right now. Otherwise, we'll end on this question. So this question is, traditionally stereo depth has been done with techniques like block matching. We're entering sort of an era of AI. Are there any AI techniques for creating depth?
Yeah, there are plenty. And this is actually a really exciting, quote unquote, exciting field. There are a lot of exciting things in AI, but the results coming out of this specifically have been really interesting for 2 reasons. One, because there is a school of thought in AI where you push more and more away, you give it less and less information to get the same result. That's really cool. Like not having a calibration to get great depth, not having full overlap in the stereo system to get great depth, having one camera to get great depth. All of these things are now being ventured. And then you have the other school of thought where it's trying to use a traditional depth pipeline in interesting ways. So that would be finding features that are AI generated to create depth, or refining your depth map given a neural network. So, when I look at it, the thing that's most exciting to me as a traditional geometric minded computer vision engineer is the latter one, because what that means is that I can still do all the things that are familiar to me, all the math makes sense, the science washes out, but then the AI just enhances those results, and I can compare that factually against what I would have had. So it gives me a little bit more security. There's no hallucination when you do it that way, right? What you get is what you get. You don't have to rely on a whole neural network having seen millions of images to do the right thing, but you still get these enhanced results that just make your process better. So when we think about hi-fi and how to better the product in the future, given our AI capabilities, that's exactly where we're going to land. That's for depth, that's for AutoCal, for MetroCal. That's where we're going to be bringing in AI into our mix.
Okay, we have one last question. We'll end it on this one. The question is, lots of companies that make depth sensors use a single infrared pattern projector, but Hi-Fi has two. Why is that?
Because of our wide field of view. That's it. So, a pattern projector just has to be unique within the field of view. So having two of the same pattern projector doesn't actually violate that assumption. All it does is give you two patterns kind of side by side, and our stereo cameras see the entire field of view. Everything has a pattern, and great depth is happening. So if we didn't have the 136 range, we would only need one, but we found that that wasn't enough.
Great. So thank you everybody for joining. You can see Brandon's email address is up on the screen right now. So if you have any other questions we didn't get to, feel free to reach out.
Please.
Just to repeat, if you wanted to pre-order a Hi-Fi, you can get an additional $50 off by using the promo code Euler at tangramvision.com/preorder. We'll follow up with an email that includes a recording of this webinar, and we'll also put it on our social media accounts. Thank you all for joining this morning, and we look forward to having you at our next webinar. Thank you.
Yeah, thank you all.